In this video, we're going to talk about sampling distributions. So we need to know a little bit of terminology to be able to do this, some vocabulary words for you. So a parameter is a fixed and unknown number that describes the population. Mean and standard deviation are the parameters that we most often deal with. And a statistic is a known value that's calculated from a sample. And it's often used to estimate a parameter. Now, when we say that parameters are unknown, that doesn't mean that we never know what the mean or the standard deviation of the population are. It just means that normally we're going to be taking smaller samples and using the data we gain from smaller samples, randomly generated samples usually, to say something about what we think the parameters are. And we need to know that different samples from the same population are going to yield different values for that sample statistic. And just like a distribution tells you what values a variable takes, a sampling distribution will tell you what values a statistic takes and how often it takes those values if you sample over and over and over. So a properly chosen sample of 1,600 people across the United States was asked if they regularly watch a certain television program, and 24% said yes. So the parameter that we want to talk about is the actual proportion of all people in the U.S. who watch the program, because our population is all the people in the U.S. The statistic is the 24% proportion that we got from our sample of 1,600 people. So that's the difference between a parameter and a statistic. The mean of the population, we use the letter mu for that, and that's a parameter. The mean of the sample is denoted by X bar. We've seen this before. It's a statistic and we use it to estimate mu. The real proportion of a population with a certain trait we call P, and that's a parameter. And the proportion of a sample with a certain trait we call P hat, and that's a statistic. And we use P hat to estimate P. Now, one little way to remember parameter and statistic is parameter deals with the population. They both start with P. Statistic deals with the sample, and they both start with S. The law of large numbers tells us that if we sample at random from a population with a mean of whatever mu, as we increase the number of observations we sample, the mean of the sample gets closer and closer to the true mean of the population. If we got the whole population, we'd have the actual whole mean. But the law of large numbers tells us we're going to get close the bigger and bigger and bigger our samples are. And X bar is getting closer to mu. It's a better and better and better and better estimate of mu. The more information we put into that, the bigger the sample we draw. So if we look at gambling, this is how the law of large numbers comes into play in gambling. So the house in the gambling operation, they're actually not gambling. They know they're going to win, because the games are defined so that the gambler has a negative expected gain per play. In other words, the true average gain after all possible plays is negative. And since each play is independent of previous plays, we know by the law of large numbers that the larger the number of customers that come in and gamble there, the closer and closer the house will come to achieving that true average that's negative. So as an example of this, the first time I ever went to Las Vegas was quite a while ago. It was over 20 years ago. And I went to Circus Circus. It's the only place we went. We were driving from LA to Salt Lake City, I think. And we went through Las Vegas, so we just stopped to gamble. And we brought in a little bit of money to play the slot machines. We went to Circus Circus. And there was this huge sign over the slot machines that said 98% return. Which means that for every dollar you put into the slot machines, you would expect to get back 98 cents. It's telling you in these huge letters to expect to lose money gambling in the slot machines. But most people saw 98% and they thought that was great. And to me, it was just advertising. You will lose this game. And so I didn't gamble. So a sampling distribution. Now we said that a distribution shows all the values that a variable can take and how often it takes those values. Well, the sampling distribution is going to show the values taken by a statistic if all the samples are of the same size and from the same population. So it shows us the shape, center, and spread. That's part of the description of a distribution. And we're going to talk about the sample mean, x bar, in this chapter, and how to look at the sampling distribution of x bar. So we're going to look at a case study in this and in the next video about this wine that smells bad. Dimethyl sulfide, DMS, is sometimes present in wine and can cause what they call off odors. So winemakers want to know the odor threshold of the human nose. In other words, what's the lowest concentration of this stuff that the human nose, most humans can detect? Different people have different thresholds, obviously. They're going for the mean threshold of all adults in the population. So let's just suppose that the average threshold is 25 micrograms of DMS per liter of wine, with a standard deviation of 7. And that the threshold values follow a bell-shaped curve. So after much research, let's say they came to this conclusion. Well, then we would expect, by the 68, 95, 99, 7 rule of the normal distributions, that 95% of individual thresholds are going to fall plus or minus 2 standard deviations from the mean. So if we do the math on that, that would be plus 2 standard deviations would give us 39, and minus 2 standard deviations would give us 11. So they're going to fall between 11 micrograms per liter and 39 micrograms per liter. But what about if we were looking at the average of a sample of 25 adults? Where would we expect values of that mean, that x bar, to fall? So that's what we'll look at next in the next video. How do we look at the sampling distribution of sample means?